All right. So this week we're going to talk about oblique triangles, congruency, solving triangles, law of sines, law of cosines. Okay? Okay, so to start with, a lot of this stuff is going to be sort of repeat of stuff that we've done before, at least for this first video. So let's start by defining this term here. An oblique triangle is any triangle that is not right. Okay? So remember, a right triangle has a 90-degree angle. We're now going to deal with triangles that are not right. That is, they don't contain a 90-degree angle. And we want to see if we can't solve those triangles. Now remember, we've talked about solving triangles before. When we're solving a triangle, remember that means we're trying to determine all sides and all angles. So we're going to determine values for all side lengths and all angle measures. We did this with right triangles, and now we're going to try to do this with non-right triangles or oblique triangles. Okay. Last, when we're looking at this list, we have congruency. Well, congruency has to deal with things that are congruent. And remember, things that are congruent are the same size and same shape. Or another way to think about congruent is all angles equal and all side lengths equal. And we're talking about triangles. Equal. And this is not to be confused with similar. So we did a whole section on similar triangles earlier. Remember, similar triangles are scaled, right? So they could be bigger and smaller, but they preserve scaling. So it's like blowing up or reducing a picture. You don't want your picture to get taller or shorter, kind of squished down. You don't want it to be distorted. You want it to look the same. That's similar. Congruent is even more basic. Congruent means they're the same. Same size, same shape, all angles equal, all side lengths equal. Okay? So what we want to think about is we want to think about, how do we know when two triangles are congruent? What do we need to know? Obviously, if we know the length of all the sides and we know the length of all the angles, then we know that that triangle is congruent. But it turns out it can be a little bit simpler than that, okay? So we have something known as the congruency axioms. So I'm going to write the congruency axioms up here on the board, and we're going to talk about them a little bit. Okay, so when we're talking about triangles, and we're talking about solving a triangle, the question we often want to ask is, when can we solve a triangle? In other words, how many pieces of information do we need to solve a triangle? And we actually answered this earlier in the semester, but just in case you don't remember, we can solve a triangle, meaning find all of the other possible angles and sides as long as we know one side, so we need to know at least one side, and any two other pieces of information. So we need 3 pieces of information, at least 3 pieces of information, and one of those pieces has to be a side. If we just know angles, angle, 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 well, that's not going to define a unique triangle. It could be any similar set of triangles, okay? So we need to know at least one side. And when we're talking about the pieces of information we know, mathematicians, we like to abbreviate things. So we're going to talk about which pieces of information we know, okay? So we know side, we could know these 3 pieces of information: side, angle, side, also known as SAS. It's a sassy triangle, okay? Now, the order matters here. This means we know a side, an angle, and a side, and the angle we know is inside of those 2 sides, okay? This guy, angle, side, side, means we know, or sorry, angle, side, angle, I can read my own information, means we know 2 angles and the side that is between those 2 angles. Maybe I'll sketch a little picture here. So if we have a triangle, lineal triangle, for this first one, right, we know one side, so we maybe know this side, we know the angle, and we know the side. So we know these 3 pieces of information. For this guy, if we have a triangle, we know an angle, we know a side, and we know an angle. And again, notice the order matters. So we know the side that's between those 2 angles. For side, 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 if we have a general triangle, we know all 3 sides, and if we know all 3 side lengths, we can fully solve that triangle. For side, angle, side, again, if we have a general triangle, oh man, my triangles are getting real bad. Go with me on this journey. And we know one side, and an angle, and then another angle. Okay, notice not the angle that's right next to these. This would fall under angle, side, angle. And we call this a SAA, or a side angle angle triangle. And last, we can talk about an SSA triangle. That means we know one side, another side, and then an angle. Okay. So these are all types of triangles that we're going to work on solving, and different techniques are going to work for solving these different types of triangle. But notice in each case, we know 3 pieces of information. We know a side length. Every one of those has at least one side length colored green, and we also know 2 other pieces of information. Okay. Now, our congruence axioms are those that are starred. So side, angle, side, angle, side, side, side. What does that mean? This means that one way to check and see if 2 angles are congruent is to check a side, an angle, a side in that order. So an angle between 2 known sides, a side between 2 known angles, or all 3 sides. If you ever have 2 triangles, right, where side, angle, sides, those are the same in those triangles, or angle, side, angle is the same, or all 3 sides are the same, those triangles have to be congruent. What does that mean for us? Well, for us, that means if we're given information in one of those 3 flavors, side, angle, side, angle, side, 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 then we're going to find one unique triangle, meaning we're only going to have one possible solution. Some of these others, we'll see, there could be more than one triangle that satisfies the conditions that we're given. We can still solve it, but we may need to solve it in multiple ways. How fun is that? Now, here's the bad news. In order to use any of these to solve a triangle, we need to develop something known as the law of sines. Right now, our sine, cosine rules, they work for right triangles. So we can fully solve right triangles if we know any of these 3 pieces of information. But we want to expand this to be able to solve any triangles. So right or oblique, remember oblique just means non-right triangles. But right now, the way we understand sines, we can't do that because our sines, cosines, tangent, we develop those using right triangle trig. They only apply to right triangles. So our goal in the next video is to develop something called the law of sines. The law of sines is going to expand our use of sines to include things that do not have a right angle. Okay? So we're going to develop that, and then we're going to use it to solve things of all of these flavors.